Consider the curve y equals x squared and the tangent at the point 1, 1. We want to estimate the gradient of this tangent. We're going to do this by using a chord from 1, 1 to another point on the curve. We can see the distance from 9 down to 1 is 8, and from 1 across to 3 is 2. So the gradient of this chord is 8 divided by 2, which is 4. We'll get a better estimate if we use a point that's closer to our original 1, 1. If we use this point, the point 2, 4, we can see the gradient of the chord is closer to the gradient of the tangent. This distance is 3 and this one 1, so the gradient of this chord is 3 over 1, which is 3. We can see that as we moved our point closer, we got a better estimate of the gradient of the tangent. We're going to continue this process using a table, as it will be less messy than continuing to use the graph. The point at which we were finding our gradient was the point 1, 1, so x1 and y1 are all 1. We've already tried the point 3, 9, and this gave us a gradient of 8 divided by 2, which was 4, and we also tried the point 2, 4, and this gave us a gradient 4 take away 1 is 3, over 2 take away 1 is 1, which was 3. Moving closer still to 1, 1, x is 1.5 and y is x squared, which is 2.25. That gives us 1.25 divided by 0.5, which is 2.5. Moving closer still, we can go to 1.1, and 1.1 squared is 1.21, so we get 0.21 divided by 0.1, which is 2.1. We could go to 1.01, very close. If we square that, we get 1.0201, and this take away this gives 0.0201 divided by 0.01, which is 2.01. We can see, following this sequence, that it appears to be approaching 2. So we might estimate 2 as a gradient for this curve at this point. We could use this process to find the gradient of the tangent to any curve at any point. For example, y equals x times x minus 2 at 4, 8. Since we're looking at the point 4, 8, x1 and y1 would be 4, 8 throughout. We'll take a point close to 4, 8. If we take x is 5, then y is 5 times 3, which is 15. The gradient then is 15 take away 8 over 5 take away 4, which is 7. But we want a closer point. 4.5, so the y would be 4.5 times 2.5, which is 11.25. The gradient is then 3.25 divided by 0.5, which is 6.5. If we take x is 4.1, y is 4.1 times 2.1, which is 8.61. Our gradient then is 0.61 divided by 0.1, which is 6.1. If we went for 4.01, 4.01 times 2.01 is 8.0601. Our gradient then is 0.0601 divided by 0.01, which is 6.01. If we take 4.001, we multiply that by 2.001 to find the y value, and we get 8.006001. The gradient then is 0.00601 divided by 0.001, which is 6.001. So we can see that this gradient is approaching 6 and would use that as an estimate of the gradient of the tangent at that point.